Okay, calculus, let's do more iterated integrals and move into 14.2. Evaluate the integral from 1 to square root of x of 2y e to the negative x dy, and then evaluate that result from 1 to 4 with respect to x. Okay, so first evaluating with respect to y, we get y squared e to the negative x, evaluated from 1 to the square root of x. This still needs to be evaluated from 1 to 4, or integrated from 1 to 4 with respect to x. Plugging in square root of x and 1, we get x e to the negative x minus e to the negative x. Now we have to integrate that from 1 to 4 dx. This is going to require us to use integration by parts. U is x, du is dx. This part anyway, we know what this one is. dv is e to the negative x dx, which means v is negative e to the negative x. So that integral becomes uv, so negative x e to the negative x minus v du, which is the integral of negative e to the x dx, should be plus e to the negative x. This integral should become also plus e to the negative x. Oh, it's minus, actually becomes minus, and then this integral minus negative e to the negative x. Now notice these two are going to cancel. So it's really just negative x e to the negative x evaluated from 1 to 4. If we evaluate that, we get negative 4 e to the negative 4th plus e to the negative 1st, it looks like, which is 1 over e minus 4 over e to the 4th, or if we get a common denominator, e cubed minus 4 over e to the 4th. Which has some value less than 1. It's a small area. We can do another one. Find the area of the region R that lies below the parabola y equals 4x minus x squared and above the x-axis, but also above the line y equals negative 3x plus 6. If we draw a picture of this, we know above the x-axis, below 4x minus x squared, that's negative x squared, plus 4x minus 4, and then plus 4. Namely, this is negative x minus 2 squared plus 4. So it has a center at 2, 4. And it's a downward facing parabola, so it should look like this. But it also wants it above the line negative 3x plus 6, which we know to be, should be this thing, right there. So it's this area. Now in the past, if we had two equations like this with all these things, we would take upper minus lower and split it into as many integrals as we need to. We can still do that because still from 1 to 2, the upper and lower integrals for y are negative 3x plus 6 and that 4x minus x squared. If we're doing y first. And then from 2 to 4, the outside integrals are just from 0 to 4x minus x squared, still dy dx. So we integrate both of these, and then we'll add them together. Integrating dy is just y, so this ends up becoming from 1 to 2, 4x minus x squared minus negative 3x plus 6. Here it's from 2 to 4, and it's just 4x minus x squared. Both of these are dx functions. namely from 1 to 2, this becomes negative x squared plus 7x minus 6 plus the integral from 2 to 4, 4x minus x squared dx. So when I integrate these, I get negative 1/3 x cubed plus 7/2 x squared minus 6x evaluated from 1 to 2 plus, looks like we end up with 2x squared minus 1/3 x cubed evaluated from 2 to 4. Okay, so we've got 2 cubed is 8, so that's negative 8/3 plus 14 minus 12 minus negative 1/3, so plus 1/3 minus 7/2 minus 6. And here we've got plus 32 minus 64/3, then minus 8, and it looks like plus, minus negative 8/3, so plus 8/3. Okay, so let's see what we have that we can get rid of. An 8/3 and a negative 8/3. Let's take all of the constants and put them together. 14 minus 12 is 2. Minus 6 is negative 4. Plus 32 is 28. Minus 8 is, looks like 20. 2, negative 4, 28, 20. Okay. See, did I miss anything? We also have, we'll just bring the 7/2 down. What about for thirds? We've got 1/3 minus 64/3 is negative 63/3. Negative 63/3 should be minus 21. Make sure we're not missing anything in the problem. Hopefully no bad math took place. Let's see. Oh, this should be a plus 6. Okay, so since this is plus 6, that adds 12, so this is really 32. So 32 minus 21 is 11, minus 7/2. So it's 22/2 minus 7/2, which is 15/2. Which is the same answer we would have gotten if we did this conversion without the double integral, because that's really what these two pieces are. But sometimes it becomes easier to see what's happening when we do a double integral. And that's all for 14.1, and we'll do 14.2 in the next video.